Hi, I'm Sophie, and this is my lab three, the bar magnet. So to outline what I'll be going over, there's a purpose, things to know, my experiment, the calculations from the experiment, coding, comparing those two values, answering the what if and why questions, and then my conclusion. So the purpose of this experiment is to experimentally determine the value of the magnetic moment of my bar magnet, and then we'll write a code to visualize this magnetic field. And then we'll compare the values um, and see what error caused this drastic change. As you can see here, the experiment one was 5.2 e to the negative 5, and the code one was 1.4 e to the negative 5. So some things to know beforehand is the Biot-Savart law, which is you have on-axis and the perpendicular axis, which I'll be using both of those in my code. And then we'll also be using this for calculating our magnetic dipole moment. Some constants to know ahead of time. 1 e to the negative 7 is this mu over 4 pi. So for the experiment, we had to line up the phone with Earth's axis, north and south poles. This is important for the what if and why questions. And then moving the phone around in comparison to the magnet, or the magnet in comparison to the phone, we calculated plugging it into this chart based on the distance. And this equation we'll also use for our calculations. Calculations. So some observations from the experiment. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. When the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. And rather than the magnetometer having no effect on the measured x component, it has an effect. So to calculate it, we used this equation, and I set it equal to the previous one to find the dipole moment. And then using the equation from the experiment graph, I was able to find K and N, and I plugged them all in to solve for the dipole moment and got 1.766. And then the chart gave us our magnetic field, which is what we're looking for in the code. So coding, I put in my values from the experiment. 1 e to the negative 7 is what as a constant we needed to know. This is our previous magnetic moment we just calculated. I used the equation previously for the magnetic field. And then this scale, I kind of just had to guess and check until I could see the errors correctly on the screen. This distance is the perpendicular distance from the chart in my experiment. These two arrows, the orange ones, represent the dipole or the magnetic field on the axis, whereas these four are off the axis. And you'll see that because ob's perpendicular. And then the magenta arrow you see represents the magnetic field 45 degrees from the axis. Okay, here's the results. As you can see, we can see all the different arrows. It calculated, or I ended up having to do work to calculate the magnetic field. Here we see that, and I got 1.42459 e negative 5 compared to the magnetic field one. And I think the reasoning for this, you'll see, is probably human error from setting up my experiment. So what if you hadn't oriented your experiment to compensate for the magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? So the magnetic field from the experiment would differ even more from the computational data because the setup allows the magnetic field of the bar to be orthogonal to the Earth's field, which is what we're looking for. So without that setup, you'd have to calculate how off the components are and account for that. So if you were to stick two identical magnets together, then it would combine and make one stronger magnet, resulting in a magnetic field that would differ by however stronger the magnet is. So in conclusion, here are my calculations from that we compared. The reason they're so off, I think, is because of my errors, which include the experimental data being skewed because my phone might have not been perfectly aligned with the Earth's axis. and human error in calculating the correct distance because of the app we used or because I measured with my phone. Thank you.